Hello students, welcome to aimstoday online classes. This is chemistry session. In this we are discussing about the chapter atomic structure. From this chapter, now we are going to say about electromagnetic radiation and Planck's quantum theory. First let us say about electromagnetic wave theory. This theory was put forward by James Clerk Maxwell in 1864. According to this theory, the energy emitted from any source like the heated metal rod or filament of bulb through which electric current is passed is continuously in the form of radiation, and it is called electromagnetic radiation. That means the energy emitted from a source is continuous in the form of radiation. It is emitted in the continuous form, and it is called electromagnetic radiation. The electromagnetic spectrum consists of waves of all ranges of wavelength or frequency. Yes, so energy emitted from different sources will be with different frequencies or wavelengths. These all energies are shown in one chart. That spectrum which is representing these all waves, the different frequencies and wavelengths. So it's called electromagnetic spectrum. It consists of the harmful rays like IR radiations, also some useful rays like radio waves for communication, X-rays for medical purpose, microwaves for cooking, etc. Yes, this electromagnetic spectrum consists of different waves with different frequencies and radio wavelengths. So it consists of certain harmful radiations like infrared radiation and some useful radiations also like visible light and some radio waves which are used for communication and X-rays which are used for medical purposes and taking X-rays and dissolve and certain microwaves which are used in cooking purpose in the ovens. Now, these electromagnetic radiations do not need any medium for their propagation. Yes, they can move and they can pass through even vacuum also. They do not need any medium for their propagation. See here, different types of electromagnetic radiations are represented in this. Is all together represented that is called electromagnetic spectrum. This consists of different types of radiations with different wavelengths and frequencies. You can see here it consists of certain radio waves at the starting, and yet there are infrared radiations, visible radiation, ultraviolet, X-rays, gamma rays. These all are there. So the chart which is representing these all radiations at once is called electromagnetic spectrum. All electromagnetic radiations are characterized by the following six properties. Yes, every electromagnetic radiation is possessing certain characteristics or properties. So let us see here one: wavelength, frequency, velocity, wave number, amplitude, and time period. So these are the properties of all the electromagnetic radiations. Let us see these. What are those one by one? First among them is wavelength. So between these all, wavelength, velocity, there are some relations between these all. They are interrelated. These all properties are interrelated one to another. Some relations between these characteristics of electromagnetic radiations can be taken as following for the calculation purposes. Yes, based upon these characteristics or properties, we do get some problems in the competitive examinations. So for that, let us see the formulae or relations between these ones. Nu represents frequency and lambda represents wavelength. The relation between these two is taken as nu is equal to c by lambda, where c represents the velocity of light. And one more relation, nu bar is equal to 1 by lambda, where nu bar represents wave number and lambda represents wavelength. So from this we can say wave number is the reciprocal of wavelength. and the time period t is equal to 1 by nu, or inversely proportional to frequency. Reciprocal of frequency is time period. So these are some relations which generally we use for calculation purposes. Electromagnetic wave theory could not explain the phenomenon of photoelectric effect on black body radiation. Yes, of course, it is explaining us about different radiations and their characteristic properties. But this electromagnetic wave theory is restricted. It could not explain the phenomenon such as photoelectric effect and black body radiation. So next, one more theory, Planck's quantum theory. As progress in the science field was happening, Maxwell's suggestion about the wave nature of the electromagnetic radiation was helpful in explaining the phenomena such as interference, diffraction, etc. Yes, these phenomena were explained very well by the Maxwell's suggestion, that is about electromagnetic radiation and its characteristics. However, he failed to explain various other observations such as the nature of emission of radiation from hot bodies and photoelectric effect, the dependence of heat capacity of solids upon the temperature, line spectra of atoms. These all properties and phenomena could not explain by this Maxwell's suggestion by using this electromagnetic theory. These properties were not explained clearly. They were not given any explanation in that. So what is this black body radiation exactly? When certain energy falls on the surface of a body, a part of energy is absorbed and a part of it is reflected and the remaining is transmitted. All the incident radiation energy is not absorbed completely by the body because ordinary bodies are not perfect absorbers or of radiant energy. So when a certain amount of energy is fallen on a body, what happens then? Certain amount of energy is absorbed by that body, and some amount of energy is reflected, and some amount will be transmitted. So this happens generally, but all the energy incident on the body will not be absorbed by that body because ordinary bodies are not completely perfect absorbers of radiant energy. However, an ideal body is expected to absorb completely the radiant energy falling on it. Such a body is known as black body. Okay, certain bodies or some hypothetical bodies which can absorb completely the radiant energy onto it. The energy, whatever it is fallen on it, if it is completely absorbed by that body, then that kind of ideal bodies are said to be black bodies. But in practical, nobody can absorb completely the radiant energy falling on it. Okay, it is just a hypothetical concept. This phenomenon could not be explained with the help of Maxwell's suggestions. So it was not explained about this black body radiation in the Maxwell's electromagnetic wave theory. Hence, Planck proposed the Planck's quantum theory to explain this phenomenon. Yes, to explain these phenomena, Max Planck proposed a theory called Planck's quantum theory. So, he explained about this phenomenon in that. Let us say about Planck's quantum theory. In order to explain black body radiation and photoelectric effect, Max Planck in 1901 presented a new theory which is known as Planck's quantum theory of radiation. According to this theory, the smallest packet of energy is called photon or quantum. In this theory, Max Planck proposed that the energy emitted by any body or any radiant is not emitted in the form of continuous form. Energy is not emitted in continuous form, but energy is emitted in small packets form. Each packet of energy is called as a photon or quantum. Okay. Substances absorb or emit light discontinuously in the form of small packets or bundles. Yes, these packets or bundles are called photons or quantum. Any substance, if it is emitting or absorbing energy, it won't be done continuously. The emission of energy will be done in small packets form. It will be discontinuous. This each packet of energy is called quanta or photon. The radiation is propagated in the form of waves. The energy of a quantum is directly proportional to the frequency of the radiation. Yes, radiation is propagated in the form of waves. As it is being wave nature, its energy is directly proportional to the frequency of that wave radiation. So energy is directly proportional to frequency of that radiation. So that can be represented mathematically like this. E is directly proportional to nu, where E represents energy of the radiation and nu is the frequency of radiation. So E is directly proportional to nu. So from that relation, we can write the energy of the quantum as E is equal to h nu, where to remove the proportionality, a constant h is taken, so that became the equation E is equal to h nu. Or in the place of nu, if we substitute the relation with the nu to the wavelength, nu is equal to c by lambda. So in the place of nu, if we replace c by lambda, it becomes hc by lambda. E is equal to hc by lambda. We know 1 by lambda is a wave number. So hc into wave number nu bar. So these are the relations which we use generally in mathematical calculations related to this electromagnetic radiations. E is equal to h nu. This is a relation between energy and frequency. E is equal to hc by lambda, which relates the wavelength and energy of the radiation. And one more relation, E is equal to hc nu bar, where wave number and energy are related. In this, h is a constant known as Planck's constant. See here, E is directly proportional to nu. From that, to remove the proportionality, a constant h is introduced, which is called as Planck's constant. Its numerical value is 6.625 into 10 to the power of minus 27 erg second, or 6.625 10 to the power of minus 34 joule second. E is equal to energy in X or joules. So here E representing energy of the radiation in X or joules. C representing here velocity of light, which is equal to 3 into 10 to the power of 10 centimeters per second, or 3 into 10 to the power of 8 meters per second. Because the velocity of every electromagnetic radiation is considered to be the velocity of is equal to be velocity of light. As we know, velocity of light is 3 into 10 to the power of 8 meters per second. And nu representing here the frequency of radiation. Frequency means we know as it is a what is the number of waves per cycle or number of waves per second. And lambda is the wavelength. What does it mean wavelength? The distance between the adjacent troughs or crests of a wave. And nu bar representing here wave number. Wave number is a reciprocal of wavelength. A body can absorb or emit energy in whole numbers of quantum. Yes, we told energy emitted or absorbed by an atom in the form of small packets. Each packet is called quantum or photon. So anybody can absorb or emit energy in whole numbers of this quantum, which can be written mathematically like this. E is equal to nh nu, where this n represents number of quantum or number of photons, and h nu is the energy of each quantum or each photon. Okay. Next, let us see some solved example based upon these relations derived from Planck's quantum theory. See the question. A green light has a wavelength of 525 nanometers. Determine the energy for the green light in joules. See the one second question. They have given the wavelength of a light radiation. Wavelength is given. And they're asking to find out the energy of that light radiation. So wavelength is given and asking to calculate energy. Let us see the solution for it. To find the energy, as we know that E is equal to hc by lambda, because here we need the relation between wavelength and energy, because they have given the wavelength and asking to find out energy from the Planck's quantum theory and relations from that. We need to take the equation which is relating energy and wavelength of that radiation. So from this we can say E is equal to hc by lambda, where E is energy, h is Planck's constant, c is velocity of light, and lambda is the wavelength. So if we substitute these all values, h we know as it is a constant, its value is fixed 6.625 into 10 to the power of minus 34 joule second, sorry, it is joule second, and c is a velocity of light, which is equal to 3 into 10 to the power of 8 meters per second, and lambda is a wavelength. They have given wavelength in nanometers. Should be converted first into SI system, because they asked here energy to calculate in terms of joules. So H value is taken in joule second SI units. At the same time, velocity is also taken in joule second, meter per second SI system. So this wavelength also should be converted into SI system into meters. We know 1 nanometer is equal to 10 to the power of minus 9 meters. So if we convert this 525 nanometers into meters, it becomes 525 into 10 to the power of minus 9 meters. So we have substituted all the values. If you simplify this, we get energy as 0.0378 into 10 to the power of minus 7 joules. So in this way, we can find out the energy, not only energy. So based upon these relations, they may give certain quantities and may ask us to calculate the remaining. If here they have given the wavelength and asked to calculate energy. Then from the same, they may ask us to calculate frequency also. Then we have one more formula, nu is equal to c by lambda. We can use this. We know the wavelength, we can calculate frequency. Okay, in this way, by using these relations, we can find out the unknown quantities from the known quantities. So here we found the energy in terms of joules. Thus, a green light has a wavelength of 525 nanometers, has an energy of 3.78 into 10 to the power of minus 19 joules energy. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos. Thank you.